This altogether can make EL client's implementation vulnerable for potential Ethereum chain consensus attacks.
Consensus bugs mostly have been taking place against the pricing model and not against the implementation itself. It's just, a high surface area in a complex piece of code, which lends to continuous attacks and improvements.
Introducing this cap does not affect any practical use case of MODEXP Precompile.
This limit isn't something which cannot be changed. While we introduce this limit right now, should the use case come around, the limit can be increased anytime in the future.
Welcome back to PEEPanEIP, the one and only EIP series where we explore Ethereum proposals for upgrades and those making an impact across the Ethereum ecosystem. This is episode 157, brought to you by ECH Institute. I'm your host Pooja Ranjan, and today I'm joined by Akash and Valeen from ECH team. In today's discussion, we are going to dive into EIP-7823, which proposes setting upper bounds for MODEXP Precompile, a change meant to improve safety and predictability in cryptographic operations on Ethereum. The proposal is documented in November 2024 and currently is in last call. This is a standard track core EIP and is being considered for the upcoming upgrade. So the inclusion state is scheduled for inclusion for Fusaka upgrade. To unpack this, we are joined by co-authors Alex Beregszaszi, aka Exec, and Radoslaw, aka Radek. Welcome you both to PEEPanEIP.
Hello, hi.
Thank you.
We usually like to start with quick introduction. Many of our listeners may already know Exec, but this is the first time we are hosting both of you together. So could you each share a bit about yourself and what you are currently working on, followed by what led you to the documentation of this EIP, so on and so forth?
Yeah, so I used to work for the Epsilon team at the Ethereum Foundation, and now I'm a part of the ZK EVM team, also at the Ethereum Foundation. And in the past, I worked on basically EVM, Ethereum Virtual Machine Improvements, OF, so Ethereum Virtual Machine Object Format, and a couple of things mainly related to the EVM. And this EIP also is a part of the EVM precompiled contracts.
It's similar for me. I used to work for a long time with the Epsilon team, mostly on EVM improvements. And this is how this EIP was on our radar. Lately, I've been mostly working on security products at Spirit and Cantina.
That's great. I understand Epsilon team had a lot of contribution in EVM development. So happy to see this proposal finally getting into the Fusaka upgrade. Thank you for sharing about yourself. And I understand we have a presentation. So without further ado, let's peep in.
Yeah, so today we are going to introduce you some context about the EIP we prepared. And this EIP, as you already mentioned, EIP-7823, and it's related to the MODEXP Precompile. And but before we start, we need first to explain what exactly this precompile is about. So it was introduced in the Byzantium fork, and basically it implements the big integer modular exponentiation, taking three arguments for the call data. They are the exponentiation base, the exponent, and the modulus. And the size of each of these arguments is uncapped in theory, which means basically that you can calculate it for as big argument value as you want. But in practice, of course, you are limited by the block gas limit, which currently is like 45 millions. And assuming the block gas limit increase in near future, hopefully near future, to 100 million, it would be possible to make a call to the precompile with the input size of 256 kilobytes, which is quite big. And additionally, the current gas model of the precompile is very, very complicated, and it was a source of many bugs already in the implementation of EL clients. This altogether can make EL clients implementation vulnerable for potential Ethereum chain consensus attacks. But Alex, would you like to add something to this part also?
Yeah, I can. I mean, basically, as a recap on precompiles, there needs to be a specific, like the gas model needs to be implemented as a specific function. The calculation is happening outside of the actual performance of the action. That's just the nature how precompiles work. And this gas model and the implementation for the gas model for MODEXP has been fairly complex, and it actually has been updated multiple times already. And another update is also scheduled for the upcoming hard fork, which suggests that this gas model is fairly complex to get right. And the consensus bugs mostly have been taking place against the pricing model and not against the implementation itself. And when we talk about consensus bugs here, it mostly has been about trying to find a bug as opposed to hitting these bugs during regular use cases. So when we talk about consensus bugs for MODEXP, those have been manually crafted transactions triggering those kind of bugs. And it's not really happening when somebody does something intended. Yeah, I think that's the key point here. It's just, a high surface area in a complex piece of code, which lends to continuous attacks and improvements.
Yeah, that was a good explanation. Regarding what exactly is the post in the EIP, so as we already mentioned, it's planned for the end of the year, so the Fusaka fork. Hopefully it will happen before the end of the year. And it's already in the last call, so absolutely every EL client should have it already implemented. But let's see what exactly this EIP changes in the MODEX precompile implementation. So basically there is one single change introduced by this EIP. And basically we reduced the input size for each of the argument to maximum 1 kilobyte. So this means that the total input size to the precompiled contract will be about 3 kilobytes, because it depends on it's exactly defined the way how the input is defined, but basically it should be at maximum about 3 kilobytes. And what happens if the input is larger than the limit? So then, of course, the precompile execution stops, all the gases passed to the precompile call is consumed, and an error is returned on the stack. And it's also worth mentioning that introducing this cap does not affect any practical use case of MODEX precompile. And they are usually related to the elliptic curve cryptography, where the MODEXP is used as a primitive to build more advanced elliptic curve ACC algorithms, or to asymmetric public key cryptography.
The interesting tidbit of information here is how MODEXP came about. There has been a proposal prior to MODEXP to support RSA verification, which has been a fairly simple precompile. And the main reasoning for that was being able to sign transactions with RSA keys and validate like existing RSA signatures, which has been used in, for example, ENS when you are proving a regular domain through ENS and not like an ENS-specific domain. So that was the origin of the MODEXP. The core devs have decided to make a more generic approach and not have like a specific RSA-only solution. And this turned out to be a good idea in some ways and a bad idea in other ways. The bad part we're trying to address now. But the good idea was that this provides flexibility for other use cases. And it has been utilized in various elliptic curve applications, but not only. And the reason we want to make these changes before going into more in-depth analysis is there are two main improvements in the short term. And the two main improvements, the first one is really you're trying to simplify the gas model. Even though this EIP doesn't actually change the gas calculation, it does make it easier to arrive at cleaner algorithms for the calculation because it doesn't have to consider as many edge cases. And the second one, which is like a short-term improvement, it makes it actually easier for ZK EVMs to have an implementation, or more specifically, have an efficient implementation. It has been possible to have efficient implementations in ZK EVM for specific. The upper bound makes it easier for the generic case as well. These are the short-term improvements, but if we look ahead in the future, this also makes it easier to create more generic implementation of MODEXP. There has been, a long-standing push to maybe generalize precompiles, and even though I don't think it's on the agenda anytime soon, I think there have been like recurring attempts at that. And a change like this would make that effort easier. What's important to mention is this number we arrived at doesn't limit any existing application. And if you look at the next slide with the actual analysis, is that we have conducted this, I don't remember now the exact duration. The EIP itself lists the starting and ending block number, which encompassed several months. And during that period of analysis, there hasn't been like any case where it exceeded 513 bytes. It has been mostly around the 32, well, more specifically 256-bit and 284-bit applications, which indicates it has been used around ECC. And there was also a spike around the 1024, 2048 bits, which indicates RSA use cases. And a 512 means the highest key has been 4097 bits and nothing above. So this validated our assumption that nobody is really using it for anything beyond like large RSA keys. We did observe a number of cases with invalid inputs, but those seem to have been either mistakes or specifically crafted to be invalid, as opposed to be something useful which has failed. It's very important to note that obviously this is a backwards incompatible change. After this, sizes above won't be able to be executed. They will end with a failure. But as I said, we haven't really seen such use cases. We haven't actually heard anyone saying that there would be a use case above this number. Coincidentally, certain zkVMs already have chosen this limit, and they have arrived at the limit independently from us with a similar reasoning. So this limit actually is already in place in certain number of chains, and they haven't really seen any negative outcomes because of this limit. So I think we are fair to say that there won't be any adverse effects, but obviously it's a breaking change. So over to you, Radek.
Yeah, so, and in the end of this presentation, I would like also to give you an update on the status of the EIP introduction. And now it's already implemented in all the execution layer clients. And it also has a dedicated like a test set in the execution spec test repository, which cover all the corner cases for this EIP. And it was already introduced to the Holeshki testnet. At the moment, like a week ago, it was introduced there. And in the next week or a week from now, it will be also live on Sepolia. And 2 weeks after, it will be already on Hoodie testnet. And regarding the mainnet update, of course, it will happen together with the Osaka fork, which is planned for now at the end of the year. Hopefully it will happen. But yeah, in worst case, it should happen in the beginning of the next year. So yeah, and that's all we have for you regarding this small change in the MODEXP precompile definition or specification. And now we think it's time to answer some questions you have for us.
Thank you for providing the overview of the proposal. This presentation was short and sweet, but it definitely makes a lot of sense. I do have some questions collected for you already. My first question here would be about the change. So the change limit, actually. This EIP puts a hard limit of 8192 bits on input. Is that limit based on real usage or just future proofing? I remember you mentioned that nobody asked to have a bigger limit, and people are generally under the limit. So just curious, what is the main reason to have this limit?
Yeah, so as we mentioned, there are two reasons we decided to introduce this exact upper bound. And the one is that basically for real usage, nobody will need higher values for this exact arguments of this precompile. And the second one was that we just analyzed the blockchain and we noticed that absolutely nobody uses it for a different sizes of the arguments. And because we wanted to make this precompile like a more secure and easier to implement, especially from the perspective of the gas model, we decided to introduce this change. Alex?
I would add maybe 2 points to this. One, the usual use case is around signatures, whether that's RSA or elliptic curves. And one of the main benefits of elliptic curves, without being a cryptographer, is it can provide similar security guarantees at a lower key size compared to RSA. And there has been always a battle to use as little data with as high level of security as possible, which suggests to me that, and it seems like, elliptic curve is kind of a winner, at least in blockchain. It suggests to me that people are unlikely to go towards RSA with large key sizes. From that, you can think that unlikely that if we stay within signatures, unlikely that somebody would need something higher. That being said, this limit isn't something which cannot be changed. While we introduce this limit right now, should the use case come around, the limit can be increased anytime in the future. And the increase obviously will need to have some research and validation that it won't cause any adverse effects. It is much easier to increase than to reduce any of these limits.
Got it. So it was mentioned in the proposal as well as during the presentation that the root problem it is trying to solve is like sometimes they create consensus bug. Like in the past, we observed some consensus bugs and we are trying to solve that problem, especially against pricing model that was mentioned. So I'm trying to understand here, were the bugs tied to extreme or unrealistic input size or in general, whatever size was at the moment?
They mostly have been clearly abusive inputs. So the way the calculation works and the way the data is formatted, because the inputs are variable length, there's kind of like a header section saying how long each of these fields are, and then the fields are coming after that. And so in order to even calculate something, one needs to parse this input and then do the calculation. And then for the processing, it needs to be parsed as well. And there have been bugs around the parsing itself, where people try to like overlap any of these fields. There have been bugs with truncation, but clearly most of these cases are specifically crafted to exploit a bug as opposed to be something useful.
So basically unrealistic parameters were trying to be passed. Okay, that makes sense. Well, my next question is with respect to failure. It was mentioned that no one asked to increase the size limit and it was found to be the most optimum one. And if some contract exceeds this, the precompile will stop. What will happen after that? Is it a safe failure or could it be breaking something upstream?
No, it's like basically when you call the precompile, you just make an external call to the contract address, which in this case is 05. And it means that if the call fails, it means that basically from the caller contract perspective, it will just return the error to the caller stack. And so it doesn't break like execution of the whole transaction.
So basically this is safe, even if it is broken. It's not having a cascading effect or breaking something really big here.
No, I don't think so.
That's obviously good to know. Well, I'm trying to understand the impact on developers and projects. Obviously, people who are working on different streams may want to learn more about this proposal. So I'm trying to understand for teams working on maybe ZK system, wallet, and bridges, do they need to update anything because of this change, or have authors received any kind of comments from DApp developers or infra team on this particular proposals?
Nobody needs to really do anything unless they try to exploit MODEXP.
All right. So that is good to know. So only malicious parties can think of using things and changing their parameters in order to make that kind of exploit. All right. You mentioned that this proposal is not directly involved in gas calculation. I'm curious, what are your thoughts on compatibility or relationship with another proposal, 7823 MODEXP gas cost increase, which is also there with the Fusaka upgrade?
It was a couple of months ago already when we were talking about this second precompile, which also changes the gas model for this exact precompile. But from what I recall now, I think it even makes the second proposal easier to define because it limits a lot of, or it cuts off a lot of corner cases from the testing surface.
So the second precompile, is it already like in form of EIP or still under the phase of research?
It's like a second change to the same precompile. Yes, it's in the form of the EIP. Yeah.
All right, that's good to know.
But they are compatible, these changes.
They were also roughly proposed at the same time, and there has been awareness from both parties.
Mm-hmm.
The way this price calculation works, it usually establishes different bands based on the input sizes. And one band has a price calculation in one way, a different band has a different way, and there's always like a fallback, for anything out of bounds, what is the calculation? Usually, I think it has been like 3 such bands in the past, and even this new proposed change keeps the 3 bands, just as the way the pricing is within those bands. And the uncapped band now has a cap, or can have a cap, and this is, the part which reduces the testing area.
That's good to know. My next question is about a mention of EVM max. I understand the proposal is already in last call, so we are considering that this is almost final and we may not see any changes. But out of curiosity, since EVM max is not currently on the Ethereum roadmap, do you think we must keep the mention in abstract motivation and rationale, or we can just skip that part for now before it moves to final?
I think it can be removed. I mean, it doesn't really hurt to have it there. As we mentioned, there are other important reasons beyond anything like EVM max. If any of those reasons are missing from the motivation, then we need to add them. I don't think they are, but we definitely going to do like a review after this call.
Yeah, so basically the EVM Max was so just to make sure that people know what it was the VM, so Ethereum Virtual Machine Modular Arithmetic Extension. And it was a set of instructions which basically make easier and cheaper from the perspective of the gas cost to implement any more advanced cryptographic primitives. Basically, the EVM Max went on the EOF, which was rejected like a couple of months ago. So this proposal was prepared before this happened. And now I think it's worth to change these motivations, so removing EVM Max, but I'm not so sure if EVM Max never happened on mainnet. Actually, I'm a fan of it, so maybe it will happen someday.
That's a good optimistic note here. Yeah, it's good to know that you people are open to review it and see if any changes could be made before it moves to final.
You have to be optimistic if you want to introduce any EVM change, actually.
Yeah, that's very true. Well, we are talking about some changes that we can bring in future and some challenges that we have faced. So I'll be curious to hear if you guys have encountered any specific challenges or any specific incident that you would like to share with the community while documentation of this proposal or maybe implementing this EIP?
No, I mean, this is really one of the more simpler ones. Obviously, the only challenge in a proposal like this is having good data, good analysis, which is convincing enough that it has covered the reasonable cases. For us, it hasn't been like a huge challenge because we have done analysis like this before. But if somebody else would like to prepare a change like this, obviously they may need to get up to speed and have to perform that. I think that's the key part for any such change. Otherwise, it's fairly straightforward.
So the challenging part is the analysis and the data that needs to be gathered for making any further changes in future. Well, my final question for you two today is about the feedback or engagement metrics that you are hoping to see or maybe collect once this proposal is live on mainnet. Have you guys thought about any metrics that people should keep track of?
I mean, this is more like a security motivated change as opposed to like a feature. So we don't really expect an uptick in use cases here, but we would hope that the number of consensus bugs may get reduced. That would be, our goal. And, hopefully we can see it with a metric, but obviously consensus bugs are multi-layered. So a change like this may not be fully enough to, get rid of them, but it certainly should reduce the number of occurrences.
Yeah, and to add to this, I think that some good sign that this is a good proposal and people like it was that when we proposed it, actually when Alex proposed it during the ICD call, absolutely every EL client was in favor to this change. And hopefully it will also allow us to make the EL clients developer life easier in the context of block gas limit increasing.
Maybe we can also keep track, I don't know how, but keep track of implementation, like how many security project is trying to implement this and make use of this. Not sure if there is a practical way to collect this metrics. Well, I think I'm done with my list of questions. Any final message that you would like to share with the community from this platform?
I would probably reiterate what Radek said in regards to needing to have a lot of optimism when proposing EVM changes. I think that would be our key message.
Yeah, actually, our main goal when we are proposing the changes to the existing precompiles is to make the precompiles better in any way, basically, especially from the security and consensus bugs vulnerability perspective, which in the case of the precompiles is very important. And precompiles are basically really nice gadgets we have in VM, but on the other hand, they are also a source of many different potential consensus issues.
Thank you for sharing that message. That wraps up our conversation on EIP 7823. A big thank you to both of our guests for sharing the context and motivation behind this proposal. Such discussions help understand the core protocol work and bring more awareness to the challenges that editor, author, or client team may feel while they are working on having an EIP bringing up to the Ethereum mainnet. We are looking forward to see this proposal on the mainnet soon. Dear listeners, if you are interested in learning more about this and want to share your experience, maybe implementing this proposal, please check out the link to discussion available in show notes, and you can share your thoughts, comments, and feedback with the authors. We thank you for tuning in. Stay connected, stay curious, and we'll see you in the next episode. Cheers.